Dear students, welcome to physics class. Let us recall the things what we had learned in the previous class. 3 points are very important. The first one is the definition of motion. First one, that is change of position of a body with the time with respect to a fixed reference point, and that reference point is called origin. Second thing is motion and rest are relative. That means to describe the state of motion or the state of rest, we always select another object, another point as reference. Therefore, motion and rest are relative. They are not absolute. Always we select another object to describe the state of rest or the state of motion. Third point is an object which appears to be at rest with respect to one observer may be in motion with respect to another observer. That means, so in a sense we can say that all objects in this universe are in motion. So these 3 points are very important. All these things we had already discussed. Today, let us discuss 2 physical quantities: distance traveled and displacement. Two physical quantities we are going to discuss: distance traveled and displacement. So, what is a physical quantity? What is a physical quantity? A physical quantity is nothing but the property which can be measured, or the quantity which can be measured is called a physical quantity. Students, we measure length, we measure area, volume, temperature, density, force, weight, etc. So all these can be measured. Therefore, we can call them as physical quantities. Among these, certain physical quantities have only magnitude. That means the quantity is indicated just by a number along with a unit. That is called scalar quantity, which can be measured and it has only magnitude. For example, temperature of an object is 20 degrees Celsius. So here, this quantity, that is this physical quantity, temperature, has only magnitude, and that magnitude is represented by a number. We know that temperature of an object is the degree of hotness or coldness. It tells us how hot an object is, and it is represented by a number. That number is called magnitude. It has no direction. So such physical quantities are called scalar quantities. What are scalar quantities? Physical quantities having only magnitude is called scalar quantity. Dear students, let us consider another physical quantity, weight. What is weight? Weight is nothing but the force exerted by the earth on the object. Here, earth and the object attract each other. We can measure how much force the earth is exerting on the object. That is, once again, as usual, it is indicated by a number. Let it be 10 Newton. And we can mention the direction also. The object is being pulled towards its center using a straight line. We represent the direction. So certain physical quantities have both magnitude and it has direction also. Did you understand? So the force with which it is being pulled, the object is being pulled by the earth, can be measured and it is represented by a number. And we can show the direction also. In this direction it is being pulled. You can mention the direction. Such physical quantities are called vector quantities. Vector quantity. So what is a vector quantity? Physical quantity having both magnitude and direction. They are called vector quantities. Let us consider distance traveled and displacement. So I would like to explain this by giving one example. A person is at A. He wants to reach B. B is the destiny. Some obstacle is over there. He can't move in this direction. First he moved towards, let me show the direction, north, south, east, west. He moved towards, first from A, he moved towards south. He covers a distance of 2 meters. Then he moved towards east and he covers a distance of 10 meters. And then he moved towards north. He covers a distance of 5 meters. Finally, he reaches the destiny, B. So A is the initial point, B is the final initial point, and B is the final point. How much distance he has covered? 2 plus 10 plus 5, that is 17 meters. The length of the actual path is called distance traveled. The length of the actual path is called distance traveled. That's all. Here it is a scalar quantity once again, because the length can be measured. The total length of the actual path can be measured. It has no direction because first he moved towards south, then he moved towards east, finally he moved towards north. Therefore, we do not consider any directions here. We consider only the length of the actual path covered by the person, covered by the object. So, distance is a scalar quantity. And distance can be measured. You might have seen a device which is used, which is in all vehicles, which measures the distance traveled, and that is called odometer. We call that device which measures the distance traveled is called odometer. Then what is displacement? So displacement is straight line path. Straight line path. So whether it is possible to move along this path or not, that is not important here. This is the initial position and this is the final position. The shortest path will be a straight line path always. The straight line path itself is the shortest path. You can say shortest path between initial position and final position, or you can say straight line path. This also can be measured. That means it has magnitude, and you can show the direction, in which direction the person has been displaced. The object has been displaced in this direction. We can mention the direction. So here displacement has both magnitude and direction. Therefore it is a vector quantity. The magnitude, it has magnitude, that means the distance covered here is a straight line. Therefore we can measure the magnitude of the path, that is the distance, and we can show the direction also, in which direction has been displaced. Therefore it has both magnitude and direction. Therefore displacement is a vector quantity. Now let us list out the differences between distance traveled and displacement. Dear students, length of the, first let me write the definition. Length of the actual path. First point. Here, shortest path between initial position and final position. Second point, distance is always positive. It cannot be negative or it cannot be zero. But displacement may be positive, negative, or zero. Consider an object starts from A and reaches B. It covers a distance of 10 meters. From B, it reaches C along the same path but in opposite direction and covers a distance of 3 meters. When we consider the displacement opposite to a direction, there we take the displacement as negative. Displacement as negative. That means displacement opposite to the earlier direction. So there we take the displacement as negative. When an object starts from A, reaches B, and again from B it comes to A, then the displacement becomes zero, because in this case final position and initial position are A only. According to the definition, what is displacement? The shortest path between initial position and final position. When an object returns to its initial position, final position coincides with the initial position. Therefore, it is zero. If it starts from A and reaches B, we take it as positive. That is 10 meters is the displacement. Shortest path is 10. Therefore, the displacement is positive, that is 10 meters. When it moves in a direction opposite to the earlier, we take it as negative. So, while taking BC, we take -3. A to AB is 10. BC, we subtract BC from AB to find out AC. There, we take the displacement as negative. When an object returns to its initial position, the displacement is 0. Third point, it has only magnitude, therefore it is a scalar quantity. Displacement has both magnitude and direction, it is a vector quantity. We will discuss the problems related to distance traveled and displacement.